Thank you for choosing DiQual, and welcome to our podcasts. Before we start, please don't forget to like, subscribe, comment, and share. It is really important to us. Hit that notification button as well, because there is more to come. You can get more detail about DiQual and our courses on our website at www.mydiqual.com. We hope that you enjoy this one.
This section is Security Practitioner 205, System Network Infrastructure, and this is Common Network Types.
There are three main categories for computer networks that describe their size and the type of connectivity that they have. These are local, metropolitan, and wide area networks, LAN, MAN and WAN. All network types exist to interconnect computer devices, and to share information and resources across them. A local area network, which is often shortened to the acronym of LAN, or LAN, is a computer communications network that interconnects various devices, within a confined local area, such as a single office building, or group of adjacent buildings that you might find in a school, or university campus. A metropolitan area network, which is often shortened to MAN, is a computer communications network that interconnects various devices, within a geographic region. The term MAN is used to describe a network that connects devices across a city, and it is often a collection of interconnected LANs. A metropolitan area network can provide uplink services to a WAN. A wide area network, which is often referred to as a WAN, joins multiple networks and locations across a large geographic area. A WAN could be global. The largest known WAN is the Internet. The World Wide Web.
This next section is about common network topology.
A bus, or daisy chain network, is one where each computer device is attached to the next, one after the other, in a sequence, or in a chain. A bus network is relatively simple to configure, and it takes minimal cabling. A bus topology can be created using media converters, to transmit Ethernet data over fiber optic cable, for longer distances. The disadvantage of this topology is that if one device fails and the bus gets broken, then all of the downstream devices will go offline. A star network topology is one that has a central hub, and the connected devices radiate from that hub. A star network is relatively simple to configure, with each device connected directly to a single hub or switch. In a star network, if a device fails, then none of the other devices are affected. If the cable link to a device fails, then only that device is affected. However, if the central switch fails, then everything will go offline. A star configuration makes fault finding relatively simple, because a fault can be quickly traced within the specific connection to a device. A tree network topology is a hybrid, in which multiple star networks are interconnected with a bus network. A tree network has a built-in hierarchy and each node can have any number of child nodes. A tree network is relatively simple to configure, as individual star networks are connected by other network devices. If one device fails, then generally the others remain unaffected. If a single switch fails, then all of the devices connected to that switch will go offline, but the other star networks will be unaffected. With a tree network being a collection of star networks, it is also relatively easy to trace a fault to a single switch or connection. A ring network is one where each device is connected to the next, and the last is connected to the first. This topology introduces redundancy in itself, because data can travel in either direction. Any device or link failure will mean that the data will only flow in one direction. The introduction of a second data ring adds more resilience, in that if either one of the rings should fail, the data would continue to flow in both directions. The advantage of the second ring is that network recovery time, after a single point of failure, is much quicker than without the second communication path. However, this topology is more expensive than the more simple versions because managed switches are required. A redundant ring protocol, such as SDP or ERPS, detects the break in the ring, resulting in an alternative path around the ring being established and data being rerouted. In a fully connected network topology, all devices are connected to each other. If one device fails, then all of the other devices remain unaffected. If a communications link fails, then an SDP will organize an alternative path. A fully connected network can be configured to report fault conditions via SNMP, but the whole network is relatively complex to configure. A fully connected network requires managed or semi-managed switches with SDP and ERPS technology.
That completes this section of audio. We try to keep narration short, because there is a lot of information contained in this section. If you want to, you can listen again, or read the section and switch between text and audio. When you are ready, you can proceed to the next section or subsection within the module.